Welcome back, everyone. Today, we are taking a fascinating explainer journey into the hidden mechanics of artificial intelligence. I mean, we use these tools literally every single day, but how often do we stop to think about the absolute mathematical miracle happening right beneath our fingertips? Specifically, we're focusing on one massive question. What exactly happens when you type a prompt?
Think about it for a second. You type a prompt, you hit enter, and bam, ChatGPT answers in, what, 3 seconds? But what actually happened inside that black box during that tiny window of time? How does a machine take your distinctly human thoughts and turn them into a beautifully crafted essay, a working block of code, or even a witty joke? Well, that is exactly what we're going to decode today by looking at the incredible under-the-hood mechanics of large language model.
Okay, let's dive into this. Section 1. Hitting enter, the input.
To really understand our prompt's journey, we first need to look at the foundational roadmap of how an AI system actually operates. It's essentially a 4-step pipeline. First up, we have inputs, or data ingestion, which is where the AI takes in the raw information. Second is processing, where it hunts for patterns within that data using some seriously complex algorithms. Third is the outcome, where the AI makes a prediction, like guessing the next word in a sentence. And finally, adjustments, where the system learns from its errors to get better next time. This entire cycle repeats millions and millions of times during training. So by the time you sit down to type your prompt, the system is completely primed and ready to go.
Moving right along. Section 2. Turning words into numbers.
So, the immediate problem the AI faces this second you hit enter is that, well, a computer cannot read English. It doesn't actually know what a letter is, so your text prompt absolutely has to be mathematically translated. The model does this by chopping your prompt up into little pieces called tokens and then mapping them into what we call word vectors. A word vector is essentially a super long list of numbers used to represent a word's exact meaning. And in powerful models like GPT-3, a single word isn't just, 3 or 4 numbers. It is represented by a staggering 12,288 dimensional list of numbers.
To put that into perspective, consider the sentence, "Fruit flies like a banana." Now, as humans, we effortlessly use our intuition and context to know that flies refers to the tiny little insects, right? Not the action of soaring through the air. But how on earth does a machine know that? Well, it uses that massive 12,288 dimensional vector as a kind of mathematical scratch space. It uses those thousands of dimensions to essentially write tiny mathematical notes to itself about the context of the word, gradually sharpening its understanding of the entire sentence.
Which brings us to Section 3. The matchmaking attention mechanism. Once your words are turned into these massive number lists, they move into the heart of the neural network. This is a breakthrough architecture called the transformer. Let's look at an example. In the sentence, John wants his bank to cash the. How does the AI know that the pronoun his connects to John? I mean, people do this completely automatically, but for an AI, it requires a revolutionary concept known as self-attention. And this brilliantly illustrates how it works. Think of self-attention as a literal matchmaking service for words. Each word creates a query vector, kind of like a checklist of what it's looking for. So the word his might create a query saying, hey, seeking a male noun. Meanwhile, every other word creates a key vector, which describes itself. The word John has a key that says, I am a male noun. The network mathematically compares these two, finds a match, and transfers the context via a value vector. So the word John literally shares its information with the word his.
Now, I want you to take a second to appreciate the sheer scale of this. 9,216. That is the number of these attention matchmaking operations that a model like GPT-3 performs every single time it predicts just one new word. It's swapping context across dozens of layers, resolving ambiguities, tracking characters, and it's doing the whole shebang in the blink of an eye.
Section 4. The feed-forward memory.
Okay, so after the attention step figures out how the words in your prompt actually relate to each other, the data moves over to the feed-forward step. And this is where the model remembers facts that weren't even in your prompt to begin with. In the feed-forward layers, the network stops looking at the connections between words and starts analyzing each word in total isolation. You can think of this layer like a giant database of learned knowledge. For example, researchers found that if you prompt the AI with the word Poland, the feed-forward layer uses vector arithmetic to add a mathematical concept of a capital city, automatically arriving at the vector for Warsaw. It's instantly pulling up learned facts, verb tenses, and complex relationships stored deep inside the network.
But how does it actually store all those facts? Well, through parameters. There are 175 billion weight parameters in GPT-3.
Think of these weights like tiny mathematical valves controlling the flow of water through a massive, sprawling pipe system. During its training, the AI was constantly adjusting these 175 billion valves, tightening some, loosening others, until the information flowed perfectly to produce the correct answer.
And to get those 175 billion dials set perfectly, the AI had to read a lot. Like a lot. Online sources estimate that the model behind ChatGPT, GPT-5, was trained on more than 70 trillion tokens of text. That is an incomprehensible amount of human knowledge. Articles, books, code, you name it, all used to fine-tune those parameters so the model understands exactly how human language works.
Section 5. Predicting the next word.
Which finally brings us to the climax of our prompt's journey. All of those word vectors, all of that rapid-fire matchmaking, all of those memory retrievals, what is it all actually trying to achieve? So the crucial point is, after all of this staggering, mind-bending math, generative AI is essentially just a giant statistical prediction machine. It uses all that context to generate a probability distribution, basically a list of percentages, guessing the single most likely next token. It picks the best word, adds it to your prompt, and then runs the entire 175 billion parameter process all over again for the word right after that. Literally one word at a time.
Section 6. Fine-tuning the final output.
But, as you might guess, a raw prediction engine isn't quite enough for a great user experience. Left totally to its own devices, it might ramble, output computer code instead of a poem, or, say something completely unsafe. It needs to be molded to be a helpful conversationalist, and this is achieved through a final layer of polish called reinforcement learning from human feedback, or RLHF for short. During this phase, actual humans score the AI's outputs. They teach it to prefer friendly, safe, and highly accurate responses. By giving the AI a reward for good answers, the model learns to align itself with human values, transforming from a cold, calculating probability machine into the highly helpful conversational assistant you see on your screen.
Now, what's really interesting about this next concept is the fierce debate happening right now among top researchers. Because these models are so incredibly good at predicting language, they can solve math problems, write complex code, and draw beautiful analogies. But some experts call them stochastic parrots. They argue that these models are merely blindly repeating complex mathematical sequences of words without truly understanding a single thing they're actually saying.
And that leaves us with this massive, provocative thought to end our explainer today. When the model perfectly resolves the ambiguity in your prompt, tracks your characters, and crafts a brilliant essay, does the machine actually understand you? Or is understanding just an illusion, created by complex math running at an unfathomable scale? It is definitely something to think about the next time you hit enter. Thanks so much for joining me on this explainer. Keep asking questions, and I'll see you next time.